that admits students purely on merit through a highly competitive national selection process. Students at the school have the opportunity to tailor their university studies to their personal interests. They thrive in a dynamic, multidisciplinary environment where individuals from different fields come together to participate in shared courses and projects while living in the same community. This collaborative setting fosters the exchange of ideas and nurtures innovation.
Thanks to this event, Scuola Superiore Sant'Anna is thrilled to welcome distinguished experts in the biomedical field as one of us for a day. They will join our community, sharing their expertise and journey with students and faculty alike. This unique opportunity to connect with such inspiring figures underscores the school dedication to creating moments of meaningful interaction and inspiration. Students will gain invaluable insights not only in the latest advancement of medicine, but also in the professional path of leaders in the field. For one day, they become a part of our academic family, leaving a lasting impact and sparking new ideas that will shape the future careers of many. The rich cultural environment led to the establishment of this lecture series. These seminars give us the opportunity to host in our school many brilliant researchers devoted to medicine, who gave us little pieces of their great research experience. Before the start of the lecture, we would like to share with you a short summary of the past edition of Horizons in Medicine and Biology through this video.
Students like yourself are very impressive to me, and I can understand that it is a very strong selection.
La Scuola Superiore Sant'Anna è ovviamente accompagnata dalla fama dell'aver formato tante persone che ricoprono ruoli importanti nel Paese.
But something very special and something very exclusive and unique, and so immediately I say, I want to be there, I want to do this lecture, and I want to know the people there and how they work, because for me it was a surprise.
Per esserci stato in passato, ma anche per fama, perché la Scuola di Sant'Anna è esattamente una delle istituzioni educative fra le migliori in Italia.
Orizzonti vi permette di conoscere e approfondire quelle che sono le ultimissime innovazioni nel campo della ricerca biomedica e di conoscere da vicino i protagonisti che fanno.
Orizzonti mi permette di esplorare temi che non sempre si affrontano durante i percorsi universitari e di capire come la ricerca e l'innovazione possono tradursi nella pratica, cosa che sarà fondamentale durante il mio percorso lavorativo.
Orizzonti significa per me futuro, ricerca e scoperta.
Relazionalità, cura e conoscenza.
Thanking Professor Freitas for being with us today, I give the floor to Professor Vincenzo Leonetti, who is the architect of this seminar, and I thank you all.
Good evening and welcome to the last lecture of this seminar collection, Horizon in Medicine and Biology. Today we will open a window in a new field, is a rising field, is a lecture out of the box, no? And actually we are not so close to this field even during medical education, but this field is rising very fast in the medical scenario, even in order to explain some diseases that actually we call idiopathic. Okay? So just some information about our professor. Rosa Freitas earned her degree in biology in 1997 from the University of Aveiro, Portugal, where she also obtained a master's degree in coastal zone science 2 years later. At the same university, she was awarded a PhD in marine biology in 2005. After serving as a researcher at the University Department of Biology until 2018, she was appointed associate professor 2 years later. Since 2011, she has been continuously dedicated to marine ecotoxicology, focusing on the combined effect of climate change and pollutants on ecologically and economically important marine invertebrates, such as mussel and clams. Her research spans from environmental chemical analysis and oxidative stress to the assessment of marine ecosystem health. With over 320 publications in high-impact international scientific journals in the field, including Science of the Total Environment, a journal of hazardous materials, Rosa Freitas is recognized as one of the leading voices worldwide in the field of ecotoxicology and marine sciences, as highlighted by the RH index of 51, Scopus H index. Her pioneering work has led to the identification of toxicity threshold for emerging contaminants such as pharmaceuticals, rare earth elements, microplastic, PFAS, contributing to the definition of standards for the protection of human and environmental health in the view of the One Health principle. Listed among the top 2% of the most influential researchers in the world in the field of marine and environmental ecotoxicology, according to the Stanford University ranking. Professor Freitas is actively engaged in teaching, research, and third mission activity. She has also coordinated numerous competitive international projects, fostering scientific collaboration with the academic institutions in Europe, North and South America, and China. She is the coordinator of the RIESCOS network, part of the CITED program. Is an Ibero-American Science and Technology Cooperation Program on emerging contaminants and climate change. This program was launched in 2020. So I'm really honored to be here with you, and I'm really excited to hear tremendous news about our environment. Thanks.
Hello? Yes. So, first of all, I have to be honest with you. Now I'm very nervous. After knowing that you are such a great student, this is just, heartbreaking to me to be here and to disappoint you. So I really hope that I can do my best to don't ruin your expectations and to meet the goal of convince you that biology is also nice. So, first of all, thank you very much, Professor Vincenzo, for inviting me. And again, I really hope to meet your expectations. and to share with you a bit what is a biologist nowadays. And let's see if I can, yes. So, just a bit of me. You already know that I'm a professor, I'm a biologist. You heard that I did all my path in the University of Aveiro, and actually I'm an associate professor, but also a coordinator of all the internships within my department. That means that all the students that want to go abroad of the university, outside Portugal or even inside Portugal, they need to talk with me. That is quite nice because I like to talk with the students, as I already told some of you. And actually, I'm also the vice director of one of the largest research centers in Portugal, largest and one of the most important research centers in Portugal. So now I'm also a vice director of CESAM. And a bit of my personal life, something that is related to you. I have a daughter that wants to be a medical, she's a medical student, she wants to be a doctor, hopefully she will get it. And I also have a boy, a son, that is still in high school and wants to be far away from sciences or health sciences. He wants to be an economist. So you can see how is my daily life at home. And probably you know this place. We were in Venice 2 years ago, or 1 year ago, 1 year ago, yes, by Christmas holidays, and these are my kids. So you know the family now. And how about where I'm coming from? So I'm coming from this point over here, that is just a bit south of Porto. Probably you heard about Lisbon, but I'm here in Aveiro. It's a very small coastal city that is called, please don't kill me, but it's called the Portuguese Venice. Why? Because we have 2 channels. So yes, I'm ashamed of doing or telling you this, but the Portuguese Venice is Aveiro. And yes, as I told you, we are in the coast, near the Atlantic, so very nice beaches. If you want to go to the beach, you should go Aveiro. The water is cold, but the sand is really nice. And we are very well known for the boats that are not gondola. They are called muliceiros, but they also travel around the channels. And this is near the sea. It's an area that is called Costa Nova, and it's a very nice touristic and nice area to visit. And this is my university. My university is quite young, a bit older than me, but still very young, like me. And we are a campus. We have all the different departments. We don't have faculties, we have departments because they are not independent from the university, from the rectory. So we have different departments all in the campus. What is really nice, because it's easier to us to exchange knowledge between the chemists, the physics, the geologists, all the fields. So this is my department, the biology department, this is the rectory, and here is just an idea about our campus. You feel sad, Alessia? Yes. Do you miss our university? And about CESAM. CESAM, as I told you, is one of the research centers in my university, and is one of the biggest and well-known research centers in marine and environmental sciences. This is the research center has students, researchers and professors from different departments, from the environment, biology, chemistry, geoscience and physics department. So we are a group of people from different fields of work trying to work together in this research center. And we are mostly related with marine and environmental sciences, but this can include the physics, the chemists, also the geologists, the environmental scientists, and of course the biologists. So it's one of the most well-known research centers in Portugal, but also in Europe. So, coming back for what I'm here to do. When I started to prepare this talk, I was not so bit, but I was afraid of talking to med students, and I was thinking, what can I tell them? What can a biologist tell to a med student? And one of the things that occurred to my mind was the fact that health should start way from the hospital. We should start to think on health not when we are on the hospital, far from the hospital. And sometimes health comes from the oceans. So today I'm trying to convince you why we should care about oceans if we should care about health. So let's try to see if I can convince you. And starting with the problem. We are the problem. As you can see, the population is growing. We are still a lot, and we will continue to be a lot, although there is a decrease in the rate of growing. And probably you know that countries like Portugal and Italy, they are decreasing the population. So we are not the cause of this growing. In fact, you can see here, Italy and Portugal, we are decreasing a lot our population. We are not the ones that are responsible for this, but we are contributing for this decrease. And probably you know what are the countries nowadays that are contributing the most for the population growth. What are the ones? Not China. They are not the reason for all the problems. But African countries, yes, in general, Ethiopia, Egypt, some of that countries are contributing a lot. And here you can have an idea. It's a nice graph where you can see with the colors where are the countries where the population is decreasing and where are the countries where the population is increasing. Of course, some countries are decreasing population because of the war, others for natural causes. And you can see that Portugal and Italy, they share the same color. So we are decreasing at the same rate, our population, and other countries are increasing a lot. So even though the problem is that we like to live near the sea. If you look to this graph, you can see that most of the population is living in the coastal area. In fact, 60% of the world's major cities are located in coastal zones. 60%. And here you can see that the major cities are all located in the coastal areas, and you can see that the orange bars are the values from 2015, and the black bars are predictions for 2050. And you can see that the predictions indicate that they even will continue to rise, to increase the population in these cities. So we like to live close to the coastal areas, and we will continue to like to live in the coastal areas. So the population will continue to increase along these areas. So my question is, why should we care? We are not going to sink, for sure, so why should we care about the fact that everybody likes to live close to the coastal areas? And this is a very nice paper published a few years ago, and authors identified 3 major causes of impacts due to the fact that we live close to the coastal areas. So, can you guess what are the 3 major impacts of living in the coastal areas? One is easy. Please don't feel afraid of saying anything. So, what are the 3 major impacts that we can have because we are all in the coastal areas? get better conditions, but at the end, we are causing damage to the environment. And one of the things that they identified is the use of physical and biological resources. We live there, and for sure you already heard about the use or the abuse of using areas along the beaches to construct, for example, but also the use of biological resources. And on top of that, the problem is that industrialization. It's near the coastal area that normally we have big companies. Why? Because they want to export the products, so sea is the best way of doing that, okay? But on top of that, we have increased industrialization and urbanization, we have an increase of use of physical and biological resources, and on top of that, we have a decrease in the resilience and the resistance of the biological sources to climate change. And I'm going to talk a bit about this later on. So, this is what we have in the field. We have climate change acting together with pollution. We have increase of CO2 due to us. We have global warming due to the increase of CO2. We have marine heat waves. Everybody knows about the feeling of extreme weather events. We have altered rainfall, sea level rise, and on top of that, we have a diversity of pollutants, metals, nanomaterials, pharmaceutical plastics, and the ones that probably you don't hear so much, it's rare earth elements. So everything acting together, what will be the result? Increase in toxicity, increased bioavailability of pollutants, increased concentrations, and at the end, we will have habitat loss, habitat modification, and the biodiversity will be at risk. So do not forget that we have all these kind of things acting together. We are not only having a pollutant in a certain area or a change in the salinity. We have everything acting together at the same time. It's like a cocktail of impacts. And in what regards to pollutants, what we have is something like this. Regardless of the type of pollutants, what we can see is an increase in the production, an increase in the production, an increase in the market. Regardless of the type of pollutant, this is what we have. We have more and more pollutants produced, used, and released to the environment. And on top of that, we have this, e-waste. And I'm going to talk a bit more deep on e-waste. E-waste is something that probably you are not aware of the impacts, but everyone has something to be related with this problem. So this is a nice image, I would say, that was published recently about type of pollutants found in mountains. And of course, plastics are on the top because, it's everywhere. But you can see that e-waste, waste from electronics, accounts 11% of the waste found in mountains. That is quite surprising because who goes to the mountain with something to pollute and is electronic or electric equipment that doesn't want anymore? So it's a bit strange to have 11% of the pollutants in the mountain can be related with electronics and electric equipment. And today, yes, I'm going to talk a bit about this. So, this was something that you don't know what it is, probably. Maybe in England you know what it is, but this was in Portugal in 1993 when I went to the university. So I need to go to this place to call home. Imagine. It's something that is hard to you to imagine how it works. But it worked. I called my mother every day I go to this machine, put a coin or a card, and call my mother. But this is your reality. This is what we have today. So we have cell phones everywhere. You can talk to your family, making videos everywhere, anywhere. So it's a completely different reality. And in fact, we have more cell phones nowadays than human beings. So more cell phones than the population. So huge. Probably you at home, you have more than one cell phone. Or at least you discard one, it's still at home, and you are using a new one. But when it comes to electric and electronics equipment, so technology in general, we are much more than a cell phone. We need more than a cell phone, and this is an example of the desk of my daughter. So, computer, iPad, iPods, smartwatch, so all kinds of gadgets in the same table to study, she tell me that is to study. But, in fact, smartphones are on the top of the devices worldwide. This is an example in US, but is translated to worldwide. Smartphones are the most popular electronics everywhere, followed of course by laptop and desktops. And here you can see that the market will continue to rise. Of course, we need all these gadgets, and we will need even more. Sometimes we have a laptop, but we need an iPad. We don't have a smartwatch, but it will be nice to have a smartwatch. So then we buy a smartwatch. So we have all these kind of things at home. So the market will continue to rise. And my question is what they have all in common. So what is the common thing from all these electric and electronic equipment? What is the common issue here? And that is what I'm going to talk about. Maybe you already saw this news. You know these two guys, of course. One better than the other, probably. You like more one than the other, for sure. And you heard about this news, right? Why Trump is so nice with Zelensky. Why he wants to be friend of Zelensky. This is because of what they called rare earth minerals. In fact, Trump is not interested to be friend of Zelensky, or he doesn't want the peace, in fact. He wants the minerals that Ukraine has. And what are rare earth elements? What are these elements? These elements are a group of chemical elements. In fact, they are 17. 15 lanthanides that are here, plus scandium and yttrium. So this is what all the electronic and electric devices have in common. These elements, all of them will need at least half of these elements to work. And the problem is, where are they? You can see that China has by far the largest reserves, but also Vietnam, Brazil, also India, Russia. But where are they produced? These are the reserves. So where we can find them? But look at this graph. The production is mostly from China. Okay? That is why Trump doesn't want to be dependent on the Chinese. He wants to be friend of Zelensky because Ukraine has the minerals and US has the technology to extract the minerals. So you can clearly see why we are dependent on Russia, on China. I don't know if you felt the difference, but when we had the COVID, the pandemic, if you were waiting for any gadget from China, AliExpress, things, or there is another one that I don't remember, but if you were waiting, even equipment that needs to have any of these elements. We didn't have them. We wait more and more during that period of the pandemic because of the pandemic, of course, we couldn't receive these elements from China. Okay? So we are really, really dependent on the Chinese in what matters to rare earth elements. And you can see that US, it's only accounting 12%. It's almost nothing. And Australia, 5%. So in what's related to rare earth elements, the production is mostly from China. And one of the things that is important to know is that some of these elements are called critical elements. And what are critical elements? What does it mean? It means that they are economically very important, like these applications that I mentioned, but they are at risk of supply. And the risk of supply can be different. Okay, they don't know where they are, they have geopolitical issues, monopolized production, as I explained, and of course some environmental and social constraints. All this together makes some of these elements called critical elements. So where are they used? For example, in a cell phone, out of the 17 rare earth elements, a cell phone contains 13 elements. So we need 13 of these elements to have a cell phone. But the applications are diverse, from hybrid cards, turbines, lighting, display screens, everywhere. In fact, they are everywhere. So, but take the example of the cell phone. Out of the 17 elements, a cell phone uses 13 elements. And something closer to some of you is gadolinium-based contrast agents. Contrast agents used in MRI images, they use these contrast agents. Most of them use gadolinium. Gadolinium is one of the rare earth elements. So there are some contrast agents that are based on gadolinium, but besides gadolinium, they can have 11 other rare earth elements in the formulation. And although we know that gadolinium may have an impact on humans, there is nothing, almost nothing about all the other elements that are in the formulation of these contrast agents. So, my question is, from smartphones to where? Should we care? Should we care about all these elements and what we are doing with them? This is a nice image to show you the amount of e-waste we are producing. And in 2016, we produced 4,500 Eiffel Towers of e-waste. Can you imagine how much we produced? And the problem is that we will continue to produce e-waste, and even more. If you look to this, we will continue to produce even more e-waste. So, more Eiffel Towers of e-waste. And bad news. While China is on top of the production of e-waste, per capita, Italy is not doing so well. You can see Italy here. It's not on the top list, but if you look of the amount of e-waste per capita, not quite well. So it's Italy, France, Germany, and of course, United States. So Italy, you need to do better your recycling. But in fact, this is a general problem. It's not only Italy. We do very low recycling of this kind of electric and electronic devices. And it's nice to see that, not nice, but yeah, almost half of the electric and electronic equipment is recycling. Okay, we are doing not so bad. 40% is not bad. But this is in all European Union. if you look for Portugal and Italy, okay, Portugal 44%, Italy 32%, but there are countries that they can do much better than us. Imagine, for example, Croatia. 80% of the electric and electronic equipment is recycling in Croatia. So it's a very good example. But also Estonia and Bulgaria, they do much better than Portugal and Italy. So, but in general, 40% of the electric and electronic devices are recycled. Not so bad. But the problem is that what do we do with the part that is not recycled? Something that is common, like what US, for example, does, they send the e-waste to poor countries in Africa. They put all the waste in big ships and send to Africa. This is true, I'm not lying, it's what they normally do. So you can see 93% goes to Asia and Africa also. But normally what we do in our countries, we do like this. We put them in piles, landfills of e-waste, and sometimes even in Europe, but it's more common in Africa and Asia. They open air burning, and all the contaminants are in the atmosphere. Imagine the pollution that is in the air. And this is something that you are used to see. People dismantling equipment without any security measures. So this is the reality. The 60% that we don't recycle, they are here, or here, or here. But the sources of rare earth elements are not only from no recycling. In fact, we can have rare earth elements coming from mining, of course, extraction, it's a problem also. Agriculture runoff, fertilizers have a lot of rare earth elements. Atmospheric deposition, of course, from industry and for the burning of the equipment. Wastewater and sewage, a lot of pharmaceuticals, as I show you the contrast agents, and cosmetics have rare earth elements, and the waste treatment plants, they don't eliminate these elements. And of course, some natural sources that are the less. And today I'm going just to speak or give you two examples. I'm going to talk about gadolinium. I already explained that gadolinium is widely used as a contrast agent, is a rare earth element, and you can see here that mostly used in MRI applications, but also nuclear technology, X-ray systems. And because of these applications, the market is increasing and it will continue to increase. So we are using more and more gadolinium. And here you can see, as all the other rare earth elements, where the gadolinium is coming from. So the reserves are mostly in China, and almost everything is produced in China. So there's no way of competing with China in terms of rare earth elements. You can see that they have the reserves, and in terms of production, they control almost everything. It's 70% of the market is coming from China. And have a look on this. This is a graph of the number of MRI exams, and you can see that since 1995 to 2017, the number of exams are increasing a lot. And these exams, 94% received these gadolinium-based contrast agents. So most of all these exams are based on gadolinium. And that is why the market of contrast agents, mainly based on gadolinium, is increasing, and it will continue to increase. And what is the problem? The problem is that although there are some studies already that show gadolinium is harmful for humans, but we can release through urine the gadolinium. But the waste treatment plants, they don't eliminate gadolinium. So at the end, only less than 40% is eliminated. So the other 60% goes to groundwater, fresh water, and to the sea. And there is a very nice study in Germany where they collected water samples from three different rivers, and they measured the concentration of rare earth elements. And you can see, look at this, gadolinium in the water. By far, much higher concentration than the other rare earth elements. And look at this. They also measure these elements in Coca-Cola. Coca-Cola from different places. And why? Because they use water, fresh water, to produce the Coca-Cola. And you can see that Coca-Cola also has a lot of gadolinium in terms of concentration. So here, look at this. So, gadolinium is everywhere, even in your Coca-Cola. Be aware. And I like Coca-Cola a lot. Oh yeah, sorry, I'm not selling the brand. But if you look to this, you can see that contamination by gadolinium is everywhere. There are some huge values in Germany, for example, and I call your attention previously to the freshwater study in German rivers. So very high concentrations, more than 1,000 micrograms per liter of gadolinium, but also in Australia, in sediments, see this amount. But in Australia is a particular case, it's close to a mining area. That is not the case of Germany. So gadolinium is in the water and sediment everywhere. And of course, if it goes to the sediment, if it goes to the water, it goes to the animals, to the wildlife. And for example, what we can see here, in Japan, in bivalves, imagine more than 30 micrograms per gram of gadolinium in a single animal. In Portugal, the values are much lower, quite good. Another rare earth element that I would like to talk about is dysprosium. Dysprosium is mandatory for hard disks. This is the most important application of this element, but also in wind turbines. And you can see the market of this element is also rising, it has been rising, increasing, and it will continue to increase. And again, if we use it, sooner or later, it will go to the rivers and to the sea. And there are several studies that already show that in the range of the nanograms, not so bad as the gadolinium, we have this element in the freshwater, groundwater, and seawater. But if you look to these two studies in Spain, they found a concentration of 6 micrograms per liter in the water, here in the estuary and here in the river. So it's not so small. It's something that you will see will cause some damage. And this is just a very nice study that it was published a few years ago that shows the publication about these elements. And up to 2018, you can see that the publications about rare earth element was increasing. The number of publications was increasing up to 40 papers. Imagine, 40 papers is nothing, in fact. 40 papers is something that I publish a year. So 40 papers is nothing about rare earth elements. But this was, okay, in 2017, this was the beginning of 2018, but here you can see that most of the studies were related with lanthanum, and lanthanum is a rare earth element used in camera lens, and the other big amount of studies was in cerium, and cerium is used to improve the efficiency of diesel, okay? So you can see that most of the studies were about these two elements. Here is dysprosium studies, and here gadolinium. Not so bad about gadolinium, but I think that there are some studies about gadolinium because also the health issue on humans arise concerns of what could be in the wild, in marine environment. So this was what was known by 2018. So, and my question is, so what? So we know that gadolinium is important because we need to do MRI. We know that this browsing is fundamental if we want, for example, wind turbines. So, why should we care? And yes, we should care and we should look for the impacts. And how we can do that? This is something that probably is not new for you. When we want to study the impact of something, we can start from We can start from genes, proteins, metabolites, so very low biological levels, and we can go up to the ecosystem. So, going up to the ecosystem is cost. It costs a lot, time and money, because imagine, to study the impacts in the population or in a community, it takes time to do. You need to have a huge impact in the community level to see something, so it's time consuming, but it is ecologically relevant because if a species disappears, it's highly ecologically relevant. But normally what we do is we go to low biological levels. Cheaper, faster, and they act as earlier warning signals. So if we want to see what is happening here, we can start from here. It will be faster to have an answer, and then we can translate up to higher biological levels. And this is where my bivalves come in. Why I'm studying the bivalves? Why bivalves are used for this kind of studies? One of the reasons is because they are sessile. They don't move. They stay in the sediment, they'll filtrate the water. If the water has pollutants, they will accumulate. Another advantage is they are very easy to collect. They don't run, so it's easy to go to the field and we can collect them. And there is a lot of knowledge about this taxonomic group. So it's important when we do this kind of studies to have a species that is spread all over, so we can compare the impact from here to China, for example. So it's very important to have a species that occurs or it has a wide spatial distribution. And of course, bivalves are very important in terms of ecology. They are food for lots of species. This is an example, but in terms of economy, they are also very important to us. It's not only you that eat spaghetti alla vongole, we also have a dish with vongole. We have a dish with clams. So they are ecologically important, they are economically important, so two good reasons to select bivalves as bioindicators, to study the impacts of these elements. And this is where we start. We go to the lab, we expose our bivalves to different conditions, and then what we do is we kill them. Yes, we need to kill them. This is one of my students. We kill them, we froze them, and then we analyze the responses. We analyze the biological responses of the animals that were exposed to different conditions. And here, I don't know if it will work. It's just some videos, but maybe I need to press stop. But this is just to show you what we normally do. So we normally, after killing the animals, we freeze them, and then we need to homogenize the tissue. We don't use the shells, we homogenize the tissue. We divide the tissue in several subsamples, and then what we do is to prepare different samples to different biomarkers, to study different biochemical responses. Okay, now we... So, after all that procedure, when we have all our samples ready, what we normally do is to analyze responses at the cellular level. And among the responses that we are interested are antioxidant defenses, you will see why, biotransformation defenses, and cellular damage. And included in antioxidant defenses, we are interested in the activity of different enzymes. These are some, as an example, superoxide dismutase, catalase, glutathione peroxidase, but there are others. We are also interested in the activity of these biotransformation enzymes like carboxylesterases and glutathione esterasperases, and at the end we want to see if there is cellular damage. Probably you know that when we are under aerobic respiration, we are producing reactive oxygen species, we humans, but the Bibles, they do the same. When they are under stress, they increase the production of reactive species. And to avoid damage, what they do is to increase the activity of antioxidant defenses. So the activity of some of the enzymes that I mentioned before. So the Bibles, they try to avoid lipid damage or protein damage by activating defenses. I also measure, and I'm also interested in measuring the metabolism of these Bibles. Not only oxidative stress, but also the metabolism. Why? Because normally Bibles, when they are under moderate stress, they reduce the metabolism. They maintain their valves closed to avoid the accumulation of pollutants. Okay? So when they are closed, they filtrate less, they respirate less, so the metabolism is depressed. And I can also measure the energy reserves, like glycogen, proteins content, or lipids. Normally, if they reduce the metabolism, they don't use energy reserves, so we have higher glycogen content, higher lipids content. But this is not the strategy that they follow if the stress is high, because they can't be closed forever. So when the stress is high or longer, they need to open the valves and increase the metabolism to defend themselves. So it's something that we can measure in the lab. And of course, I'm always interested in neurotoxicity because most of the pollutants are neurotoxic. But besides the cellular impacts, I can go up to individual level and I can measure respiration, regenerative capacity, also filtration. And this is just an example of how we can measure the respiration of the bivalves. We have equipment where we put the animals, and then every 15 minutes we measure the respiration by measuring the content on oxygen in the water. It's quite easy to do. It's a bit boring, but it's easy to do, to measure. And of course, we can go even higher in the biological level, and we can measure alterations in tissues. Normally, what we do is to investigate the impacts in the gills and digestive gland. Why gills? Because gills are the first organs to be in contact with pollutants. Why digestive glands? Because it's the organ where they biotransform or eliminate the contaminants. So normally what we do is this process, and at the end we are interested to see the malformations in the gills and in the digestive gland. So now after all this work, the results. So now you are convinced that rare earth elements are harmful, I hope so. You are convinced that rare earth elements, namely gadolinium and dysprosium, is everywhere, including animals and wildlife. So now the funny part, I would say, the results. So let's start with gadolinium. You can see that this is electron transport system activity, so the activity in the mitochondria. And you can see that there is a huge decrease in the activity of this electron transport system when the animals are contaminated with gadolinium. And here, because they are decreasing the metabolism, they are increasing the content in glycogen, up up to a certain level. Because when the stress is so high, they need to start to use the energy reserves. There is no way of maintaining the content of glycogen. They need to use it. And how about antioxidant defenses? It's clear that they start to fight against gadolinium. The antioxidant defenses increase. And again, when the stress is too high, there is no way to continue to increase. And this has happened with the two of the antioxidant enzymes that we measured. And how about biotransformation? Again, they can increase the biotransformation up to certain levels. If the stress is too high, there is no way to continue to increase the activity of these enzymes. And they are neurotoxic too. We measured the activity of acetylcholinesterase that was inhibited, and this is a sign of neurotoxicity. So gadolinium is also neurotoxic. How about dysprosium? I'm not going to go in details as I went to with gadolinium, but here it's a multivariate analysis with all the biochemical parameters that you measure, and you can see that this is the control, low concentrations and high concentrations. No doubt that increasing the concentration of dysprosium, we will increase the impacts. And we know that the market of these elements will continue to increase, so more concentrations in water, more will be the effects. But I need to pay attention to the fact that pollutants are not acting alone. As I said at the very beginning of my talk, there is not only one pollutant or only pollutants in the environment. This is the graph of the population growth, and this is the greenhouse gases curve. You can see that they match perfectly. We increase the population, we increase the emissions. And what is a problem? And I'm pretty sure that you are aware of this. Increasing the emissions, we have global warming. And this is just a zoom in the recent years. You can see the increase of the temperature in the atmosphere. This is real. And the problem is that the oceans, they absorb 93% of the energy. So if we are warming up the atmosphere, we are warming up the oceans, because all this heat in the atmosphere will be absorbed by the oceans. And this is an image of what is happening in the last years. So we are increasing the temperature in the atmosphere, but also in the oceans. And there are some ones that don't believe that this is true, but yes, this is true, and this is the scenario. We will continue to have an increase in the temperature if we don't do anything. And probably you already heard about coral bleaching, so warmer temperatures, we will kill the corals, not kill, but at least damage them, because the symbiotic zooxanthella that lives with the corals will be released due to temperature. But something that probably you are not aware is the fact that increasing the temperature will increase the metabolism of cold-blood animals, like fish. And something that is really interesting to know is that the concentration of mercury in the North Pacific is increasing, and it will increase 50% more in the next years. And do you know why the mercury is increasing in the North Pacific? Guess. Why we have more mercury now in the Pacific? One of the reasons is because of the melting of the ice caps. And mercury was trapped in the ice sheets, so now with the melting, it goes to the sea. But also because we have more emissions nowadays. And also we have more runoff because of extreme weather events. So we have more and more mercury in the ocean. And remember what I said before, cold-blood animals will increase the metabolism. So what will be the problem? More mercury with higher metabolism, it's the perfect mixture of events. So animals will need to eat more because the metabolism is increasing. So if they eat more, they will accumulate more mercury. So this is a problem that we need to think about. It's not only a matter of pollution, it's a matter of climate change acting together. So, in fact, when we have climate change, we need to think that climate change related factors will act on the animals, they will be more sensitive, but these factors will also act on the pollutants. Some of the pollutants are much more toxic when, for example, the temperature is high or the pH is low. And this is the case of mercury. I was talking about mercury. Probably you heard about Minamata disease. Minamata disease, it's called Minamata because it was found in Minamata in Japan. It is a neurologic disease due to mercury consumption from fish from a river. So years ago, I think it was in the 50s, they found that mercury was neurotoxic, and they found that why? Because the population surrounding this river started to have neurologic disease. So mercury is a concern still nowadays because we still use mercury in a lot of different applications. And the problem is that the organic form of mercury is much toxic than the inorganic. And how we can have organic forms? High temperatures, low pH, and salinity also plays a role on this, with low salinity promoting the methylation of the mercury. Because the methylation is done by bacteria, they like warmer temperatures, so warmer seas will have more methylmercury that is much more harmful than the inorganic form. And this is a quick show that proves that in fact, when we have the two factors together, the impacts are higher. Here you have the control, so no mercury, no climate change. Here is mercury at 17 degrees, that is the control. But look what is happening when we have mercury plus warming scenario. The impacts on these antioxidant enzymes are much higher compared with only mercury. See? In both cases, if you only have mercury and if you have mercury with warming. So the impacts are higher if we have both together. And this is the same for arsenic. Arsenic, we also talked about a bit about this. Arsenic is also present in a huge diversity of water sources, including groundwater. And here you can see also that arsenic with high temperature is much more toxic than arsenic at controlled temperature. So there is no doubt that when we have both factors combined, pollutants and climate change, the impacts will be worse. And this is what happens with gadolinium. So look to this. In the case of gadolinium, the presence of gadolinium will increase the activity of the enzymes. But if we are talking about warming conditions, the defenses are much lower than at control conditions. Although they are able to increase the antioxidant enzymes, in fact, compared to the control, much lower the capacity to defend themselves. So, like mercury or arsenic, gadolinium will be also more harmful under warming conditions. And here you can also see the biotransformation is the same, lower capacity of biotransformation, of lower capacity of elimination under warming conditions. And again, dysprosium. You can clearly see that doesn't matter on the temperature, dysprosium will have a huge impact on bivalves. In this case, it's not like gadolinium. In this case, warming alone will have a huge impact, but dysprosium overlaps the impact of the warming. And when we talk about climate change, we also talk about extreme weather events. And when we talk about extreme weather events, we talk about droughts and rain, of course. And this will have a huge impact on salinity. And this is a nice image to show you what is going on in terms of extreme weather events. Floods are the most common, but in general, extreme weather events will become more frequent, more intense in the coming years. And the problem with this is that salinity is one of the most important physical-chemical characteristics of the water for osmoconformists, like bivalves. Bivalves are in this line, so when the environmental salinity changes, they need to adapt the inner fluids to what is external. So this is very costly in terms of energy for a bivalve to maintain isotonic fluids. So salinity is something that is changing a lot. If you imagine that, for example, in my history in Aveiro, a week of rain can drop the salinity more than 15 units. So it can go easily from 30 to 15 of salinity just in 1 week. Although these animals are used to tides, they are not used to such a low salinity stress. So now think about the stress of this salinity change plus pollutants on top of this. And again, you can see easily what is the impact of having together gadolinium and low salinity. You can see that the metabolism under low salinity increases a lot compared to control salinity. And again, antioxidant defenses increase a lot. So the stress under the presence of gadolinium and low salinity, it's even higher than under control salinity or salinity 40, because salinity 40 in fact is close to what they normally are used to eat. And again, you can see that gadolinium increases the biotransformation capacity, but low salinity induces a higher stress. And at the end, regardless of the salinity, we will have cellular damage. So lipid peroxidation was observed in any of the salinities, higher here, probably because the defenses were lower at this salinity. And again, the same for dysprosium. You can easily see that these are the conditions with dysprosium, these are the conditions without dysprosium, and again, dysprosium overlaps the salinity effect. So dysprosium is quite heavy in terms of toxicity. But again, they don't act alone. We have mixtures of pollutants. And mixtures of pollutants can have different responses. They can give an additive response if they sum the effects. They can be antagonists, they can be synergistic. So, what is going on, for example, when we have gadolinium and microplastics? That is a common mixture in the environment. You can see that this is the mixture. This is only microplastics, this is gadolinium, and this is the control. Clearly, the impacts on gadolinium are very different from the other treatments, and the mixture will induce different impacts, maybe a bit higher than when the gadolinium or the microplastics are alone. And how about dysprosium? It's the same. We tested a mixture of rare earth element, so this is single exposures regardless of the temperature or the salinity, and this is the mixture of rare earth elements. And again, you can see clearly there is a different response when you have a single element and a mixture of elements. So imagine how this cocktail will be in the environment, because in fact here we tested 5 elements together, but in the environment we have thousands. So, to sum up, and I think, yes, I need to finish. Although we don't have mortality when we do these tests in the lab, normally we do an exposure of 28 days, and normally we don't have mortality. But should we care? Yes, of course, because even us, we don't die, but sometimes we are sick and we want to be alive. So the animals are the same. So what can we say? they have costs. Of course, there are costs. If the animals are exposed to any of these elements, of course, they are fighting against the stress imposed by these elements, so they are probably not ready to defend themselves from other disease, for example, or they will have impacts on the growth. Probably they will grow less, and even they can reproduce less, because they are using energy to defend themselves against the pollution impacts, but of course they need to have also energy to reproduce. So if they are using energy for one of the problems, they can use for the other. And what is the problem? One of the problem, of course, is socioeconomic impacts. We like plants, we like Bibles in general. If we don't have them enough, we will have to expend more money to buy them. So this is a cost. But of course, we have ecological impacts, because bivalves are food source for a huge diversity of species. And at the end, what I want to call your attention is that if bivalves are not okay, it means that the ocean is not okay. So it means that we will not be okay, because we eat them. So on behalf of the One Health perspective, be aware that if the ocean is contaminated, wildlife will be contaminated. If we eat them, we will be contaminated too. So we really need to care about this. And just to finish, I would like again to thank Professor Censo for inviting me. It was really an honor to be here. I really hope that I touch your hearts in terms of pollution impacts, and I hope that you are still alive, breathing less, reducing the metabolism, but still alive at the end of my talk. Thank you very much.
Thank you very much, Professor Freitas. Was a brilliant lecture, because for medical students it's not very common to hear about this issue.
I hope you are alive.
Yeah, and there are also different impact of this exposure in the onset and even the development of disease. Just while you were showing your slide, I was thinking about some, when you talk about reproduction, so there is an increasing rate of sterility and problem infertility in the population, and people think that is unrelated to these issues, but it's not, because there is a really tough impact on the reproductivity of the human being. Is it correct?
This is correct, and in fact we did a study in our university with students. We asked students to give sperm, and we measured the activity of the sperm and the velocity. And the students that smoke, for example, or they were exposed to some sources of contamination that we identified, they have lower chance to reproduce. We saw that in humans. And of course, sometimes we do like Alessia did with the gametes of bivalves, and we also see a strong impact in the reproduction. But it's not only in bivalves, in fact it happens in humans.
Yeah, and even in foods that we can find around, they are commonly available, like Coke, as you can see, but it's really rich of gadolinium. And gadolinium is really toxic. Actually, in the MRI unit, we find a huge amount, an increasing amount of subject intolerance and allergic reaction to gadolinium during the MRI. And in the past, these reactions were uncommon, rare, and sometimes undetected. So we were not ready to counteract this strong reaction during MRI test, maybe because the continuous exposure to the gadolinium in the environment sensitized us. And so our immune system now reacts strongly, because now there is an increasing literature about allergy to gadolinium during MRI test. It is a really typical phenomenon in patients because they have a strong, difficult to breathe, but even a strong inflammatory reaction in the eyes. So it's quite different to other type of allergic reaction. However, as you can see, maybe you can find the explanation to different diseases, even neurotoxicity, because it's quite increasing the amount of patients affected by neurodegeneration, actually. And it is interesting to see that this population of patients is much more concentrated in the area with the river or close to the coast. Yeah. So maybe this could be the reason. Okay, so any question? I mean, if you think about this presentation, you can have several questions to ask. Okay, please come, no, here, to the microphone. So they learn how to ask questions during a meeting. So please introduce yourself.
Hello, I'm Aurora. I'm a student of Natural and Environmental Science. I'm in my first year of Bachelor. So first of all, I would thank you for your brilliant lecture. And I would ask you if now that you and your research group have analyzed these problems and yes, made from these elements, if now are you going to start collaboration with other research groups in order to develop some technologies in order to resolve this problem? Maybe some research groups that could approach this problem from a more engineeristic point of view, or in general, if do you have some solutions? Are you working in some projects in order to yes, give solutions from to this problem? Thank you.
Thank you for the question, and thank you for being the first one, because it's always harder to be the first one. So yes, my answer is yes. I'm collaborating often and closely with the chemistry department at my university. And why? Because they are developing nanoparticles that are able to remediate the water from these contaminants. But another thing that we do is, also with the chemistry department, they are using algae to remediate the water and improve the quality of the water and reduce the impact on bivalves. And this is already published. In fact, we have several published articles about this, the capacity of different species of algae to remove these contaminants. And the step that we want to go now forward is how we can use the elements that are accumulated in the algae, especially the critical ones. And there are two companies that are funding a project that we have, because they are very interested, of course, in these elements that are in the algae, because as I said, they are critical, so not so much of these elements everywhere, and they are important. So these companies, what they are doing is funding our research to see how we can take the elements back from the algae and use again these elements. So there are no doubts that the elements are adsorbed to the algae, so the water is in a better condition. But now what we want to do is to know how we can use again these elements that are in the algae. But I need to call your attention to the fact that in the environment we have bivalves and algae. And the algae are already doing the role of taking out the pollutants. So imagine first, how are the algae in the environment? Be careful of eating some of the algae. And on top of that, if they are remediating the water, how much is the amount of pollutants that is arriving to the water and we are not measuring because the algae already absorb them? Okay, so good question.
So no Japanese cuisine.
Yes, no tea.
Forget about. Okay, so other question from the audience? Yes?
Good evening, I'm Matteo. I'm in my second year of medical school here at Scuola Sant'Anna. So thank you for your amazing presentation. I was wondering something. I mean, these data could be really useful to make policies in order to, of course, not allow the increasing in pollution. And I was wondering, in your experience, has Portugal or the European Union, has it been, listening to your data? It is easy to, dialogue with them to make policies, or do you feel that economical interest is, in a way, overcome these scientific evidences?
That is a very hard question because, yes, we try always to disseminate our results, especially to policymakers and to the ones that legislate. But that kind of groups are not so sensitive to the impacts on the environment because, money talks louder than all the rest. But although we are not still in the point of having a legislation for these elements, we are approaching that. I know that the European Union is working on a report on the impacts of rare earth elements. They are preparing some guidelines, not rules with specific levels, but some guidelines. But I really think that this will take time because we need to explore the rare earth elements in Europe to avoid to be dependent on China. And I think that is the problem why the European Union doesn't want to have fixed and strict rules about this, because they know that we need to have mines in Europe. But yes, they are starting to think about this. They are preparing some reports since 2 years ago, I'll say. Even the President von der Leyen, she already mentioned rare earth elements in some of the talks that she made. So I truly believe that this will come sooner or later. There is something to come. And yes, thank you very much.
Other question? It's not, it's a very quiet environment. Okay, thanks. And your English is better than mine, so no problem.
Hi, and first of all, thank you for your lecture. And I was wondering if there were other studies about the effects of gadolinium in other sea species other than clams, for example.
Yes, there are some studies with freshwater invertebrates, like daphnids, for example, but also some sea urchins. There are studies with sea urchins also, and fish. Yes, fish is always a good model to study because it's the most similar, let's say, to us. So there are some studies with fish, although all the ethical issues that sometimes is difficult to work with fish because of that. But yes, I would say that more than bivalves, there are studies with fish on this topic, yes.
Actually, this information are very useful for physicians that need to decide which kind of diagnostic approach follow, and even to don't use too much diagnostics like MRI, just because they don't know how to detect the signs and symptoms of patients. They don't visit patients, they read the certification from the radiologist and just to go to the diagnosis. And actually, this could be a huge point of discussion, because even the therapy, people like lithium, okay? And the lithium, someone use not in a proper manner, and they still administer lithium without a reason, because they don't want to wait. They don't want to wait the recovery, because the social environment is not ready to support this type of patients. So you need to solve a problem very fast. And you contaminate the environment to urine with lithium. And I know that the toxicity of the lithium is dose independent. So it could be possible that toxicity of other rare earth elements could be dose independent in human. Just you have a progressive deposit of these minerals in the tissue, like happened with the lithium.
The rare earth elements that I study, most of them, they are dose dependent, the impacts.
Dose dependent.
Also lithium in bivalves. I have several papers on lithium, and lithium is also dose dependent, but not as harmful as rare earth elements. And I would say that the reason why is because the seawater is full of lithium, so the animals are used to the lithium, because the levels of lithium in seawater is like 150 micrograms per liter, so it's a lot of lithium. In fact, there are companies trying to recover lithium from seawater just because of, yes. But for example, in Argentina, they also recover
lithium from the sea.
Not from the sea,
the river.
From the river that has also some salt in that area. So in Atacama Desert, for example, in Chile and in the north of Argentina. But our coastal area, for example, in the Atlantic, the main value of gadolinium is 150 micrograms per liter. So it's quite high. So when we test gadolinium in the lab, what we do is we double the concentration just to have an effect. And it's quite clear that is dose dependent, like rare earth elements in general. And I tested already, I would say, 8 or 9 rare earth elements. But normally what I do is I use environmentally relevant concentration. So I only test concentration that I can find in the environment. So I don't push to the limit. I don't want to see that the animals will die. What I want to see is if the concentration reaches what is in Australia, in China, in polluted sites, that it's something that is real, what happens? And by far, most of them are dose dependent in terms of the response.
Yeah, the threshold is the key answer, because even the policymakers are based on the threshold. Okay? But the lithium, if you administer lithium and you dose the lithium in the bloodstream and you detect very low concentration of lithium in the bloodstream, the patient is affected by several signs of organ dysfunction. that's why physicians say that these doses are related, because is time related. I mean, if you have a chronic treatment with a small dose, it's much more important the time of the exposure rather than the dose of exposure.
It could be the same with the wildlife, but I can't say that because normally the longest exposure are 1 month. So I would say that chronically exposed animals could face something like that. But normally I expose, and normally all the studies are exposures of 28 days or 21 days, so we can't see much about the time effect, because normally the exposures are more or less with the same length. But maybe it could be something like that, yes. We can probably figure out that it's not a dose-dependent response if they are exposed for a longer period. Yeah, it could be.
Thanks. So, other question? I want to say something to the future, to the physician of the future that are in the room today. The hospital are the main factory of pollutants in the world and are not under the control of the policymaker, the hospital. So all the environment related to health is one of the uncontrolled source of pollutants, like microplastics, like phthalates, like the other endocrine disruptors that are released from the plastic that we use to give blood of saline solution, crystalloids, colloids. No, they are packaged in the plastic bag. And I want that you say to these students the story about the surgical block and the risk related to this environment.
Yeah. There are some studies that point out that in the surgery block, the exposure to PFAS, for example, is huge. You or the ones that are working on the block, they are more exposed than any others to PFAS. Even the Teflon pans that we use at home, that is a good source of PFAS, but we don't use that every day. And if you are a doctor and if you are always using the mask, the gloves, and the things that you need to dress, you are exposed daily. So yes, you should be aware of this kind of things. And
people, I didn't know that, and people don't know about this. And if people start to know, and maybe can develop some new approaches and even new materials to obtain clothes, to produce cloth, mask and hat and the other stuff that regularly we use in the surgical room. And even from the side of anesthesia, there are some drugs that already are banned, like desflurane. Desflurane is an halogenate gas, is a volatile anesthetic that is really is toxic, is a huge pollutant for the environment, and actually in my society, the Italian Society of Anesthesia, there is a working group. This working group was launched this year. There is a working group that is focusing on sustainability and pollutants and contamination of the environment by anesthetic drugs. And so you need to make a choice related to the environmental impact. And actually, they are doing this for some drugs. So even I'm thinking about fentanyl that is contaminated, is a synthetic opioid, so maybe there is a huge contamination even of fentanyl in the environment.
I'm quite sure that there are some studies about that, because there are studies about most of the pharmaceuticals used under hospital conditions. When you have a patient in the hospital, there are several drugs that are used daily, and the ones that are used under these conditions in the anesthesia. But the problem is that, yeah, you need to save lives, of course. The problem is that the wastewater treatment plants in the hospitals are not prepared to eliminate them. And that is the problem. I would say 99% of these plants are not ready to eliminate pharmaceuticals. So that is why they will reach to the environment. So I think we need to think about the solution to improve the elimination process, the efficiency of these plants, to eliminate more of these pharmaceuticals, because of course we need them. But the way of doing this probably is to be aware of the impacts and try to develop solutions to get a higher elimination rate in the wastewater treatment.
We need drugs, but sometimes there is an abuse of drugs and even an abuse of dose of drugs. You need to touch the twist of the patients and understand how it's going on. I mean, before to give drugs and before to say, okay, go ahead to give a higher dose of the same drug just because you feel better and I'm happy that I don't see you around in the next 2 months, okay? I mean, physicians are not sellers of drugs, but you need to design the therapy on the shoulder. And actually the precision medicine could be the answer, the personalization of the treatment could be the answer to this huge problem. Believe me, I don't know I can say, is really, is so huge that we like to close the eyes to say that the problem does not exist, but it is around us and it is exists. Even I don't know if someone related this type of this graph of contamination that show the increase of some substance in the environment with the increase of with the incidence of some disease in the last year.
I know that there are some studies on COVID, and they followed some of, for example, paracetamol, ibuprofen that were quite used during the pandemic, and there are some studies showing the increase of this kind of drugs in the environment associated with the pandemic. But I would say that there should be other studies also related.
So they are not studies like this. I mean, increased gadolinium. I mean, increase.
With gadolinium, I don't know any. No. No.
So, let's move to study this relationship and try to understand if there is a relationship of drinking Coke and the onset of some disease. That we know that if you drink Coke, you can develop some metabolic syndrome or diabetes type 2, but maybe people think that it's related to the sugar.
Maybe not.
Maybe not. Maybe it's related to other stuff.
In Germany, the amount of concentration of gadolinium is quite huge in Coca-Cola. So if you go to Germany, be aware of that.
Okay, so if there are not other questions, I will say thank you again to Professor Freitas. And now I leave the words at the stage to our delegates of medical students and even